Hello students, welcome to Arjun my classes. What we'll do today again, we are going to solve the problem on LPP by graphical method with another kind of a problem here. So what we done is we solved problem with the maximization and minimization, and their conditions they used to give greater than or lesser than in a common way, means both sides they used to give less than equal to or greater than equal to. Now what we do, we'll go with the other problems like a mixed conditions, nothing but some one condition will be greater than condition and another one will be lesser than. So that time what happens, it will give another solution. So that kind of solutions what we'll call. So regarding that we are going to teach today. So just please go for the second problem.
Hello students, we have one more problem on this graphical method, and same thing yesterday what we discussed, the same problem. So here you can see this, the symbols what we have here, so they are of different signs. You can say this one is a greater than equal to and another one is less than equal to. So it is having different this kind of problem we'll call as a mixed problems. Okay, so coming to this, the procedure is again same thing. There is no difference in this procedure for the graphical method. First step is we have to convert the given problems into the equal problems now. So it is an equal problem, right? So what we do, we'll convert that one. X1 plus x2 is equal to 4, and similarly for the second equation, x1 plus x2 is equal to 1. So next work is what we converted. The step 1 is done. Second one is we have to proceed for this. We have to get a coordinates to plot the graphs. So what we'll do, we'll just write again the equation number 1, x1 plus x2 is equal to 4. So to get this, what I will do, I will follow this method. Put x1 as 0 in the equation 1. So then x2 is going to become what? It is going to become 4. If we put x2 as a 0, so the x1 is going to become 4. So this is for the first one. Similarly for the second one, x1 plus x2 is equal to 1, and uh, we are going to put a x1 equal to 0 here. So then x2 is going to become 1. When we put x2 equal to 0, so then what happens, x1 is going to become 1. Means we plotted all these things and we got a graph. Yes, we will go.
Students, coming to this graph, so you can see this. We just taken the coordinates for both the equations here, x1 plus x2 equal to 4. This is the first equation. So that when x1 is 0, that time x2 was 4, and when x2 is 0, x1 value was 4. So then what I will do, I will represent the first one. When x1 is 0, x2 is 4, and similarly second one, when x2 is 0, x1 value is 4. So I represented this one. Next what I will do, I will join these two. Okay, so we did for the first equation. Similarly for the second equation, you can see this. When x1 is 0, so that time x2 x1 value was 1, and similarly for the second one, you can see this. When x2 is 0, x1 value was 1. So then what happens, so equation become like this. So we joined these two. So now we already know, so the feasible reason is decided by what, this conditions, whatever the conditions they given, greater than or equal to or less than equal to. The greater than equal to, whenever we have greater than or equal to, so that time the feasible reason will be above the reason. Whenever we have less than equal to, the feasible reason will be below the reason. You can say this, the first equation, it is greater than or equal to. So greater than or equal to means, you can say this is above the reason. So greater than is given, so then feasible reason will be located in this part. So it's above the line. So you can say this, above the line it will come. So whenever we have a less than equal to, so that time feasible reason will be located at the bottom of the line. So this side it will be. So then you can say this, we got any common reason here, we didn't get any common reason. So then this problem is not having any solution. Hence we need to say that, hence the given LPP is not having any solution. So what this is a kind of, this comes under infeasible solution problem. Okay, This comes under infeasible solution type. So thank you.